Welcome to a brand new episode of Machine Learning Made Simple. Here we unravel the enchantment behind machine learning, demystifying all the technical jargon. I'm your host, Shogato, and I'm here to chat with you about the revolutionary changes unfolding right before our eyes in the tech world. Let's dive in. Welcome everyone. Today we are diving into the rapidly evolving world of robotics. This is a field that's not just advancing but transforming industries, and soon it will transform our daily lives. That's why we need to pay special attention to advances in the robotic world right now. So one of the most talked about developments was the Tesla's Optimus humanoid robots that they just featured recently. And you might have watched the videos online. I also posted those videos. So this is just no longer a futuristic concept anymore. Companies like BMW, General Motors, and all the other car manufacturers are integrating these second generation Optimus humanoid robots into their assembly lines and is essentially removing human beings from those hazardous assembly line procedures that has claimed many lives over the years. The dream of robots handling hazardous and monotonous tasks dates back all the way to the 1960s. Those early automations failed because we couldn't create those humanoid robots. We didn't have the technology back then, but it did get into building the specialized machinery which can perform very specific functions. So we did develop some machinery which helped with those dangerous processes that human beings had to indulge themselves during the manufacturing process. So these massive robotic arms that were packing boxes and centrifuges which are mixing ingredients in food productions, that really helped and isolate human beings from dangerous manufacturing processes. But these systems were groundbreaking then, but they lacked the adaptability of human beings. So later you might have noticed the conveyor belt sorting mechanism. Those were implementing using computer vision. In fact, there is a famous problem which shows how to sort fishes because certain fishes look very similar, and how to sort them in a fishing line. So those are manufacturing processes. Yeah, that's not a dangerous task. Sorting fish is not a dangerous task. Maybe the danger of stinking the whole day. But other than that, there are certain tasks has been fully automated using computer vision. But there are certain tasks which only the dexterity of human beings are needed, like car manufacturing, putting on an exhaust manifold, or the engine manifold, and all those things in a manufacturing facility. And those are heavy machineries that they have to haul, heavy parts they have to haul. A slight mistake can cause a severed finger, or at worse a severed limb maybe. So when we replace human beings with those humanoid robots which can perform, maybe not with the same dexterity, but they can perform those tasks and it doesn't cause any harm to human beings, that's the vision that we are all progressing towards. Now we can have these robots which can do their tasks, and they can do it relentlessly. And we'll see a video later where we can see the BMW robots are work tirelessly. Human beings get tired after 6 hours or 8 hours of exhausting manual labor, but these robots don't get tired. They'll just go charge themselves and just come back and start working again. So the the efficiency goes up like 100,000 times. It's crazy. Yes, some human beings will lose jobs, but those jobs should not be done by human beings anyways. They should move from those jobs to some jobs that requires more human intelligence, not just using of human hands and limbs, and which can put the human lives and limbs at risk. So these are the things that we're going to explore in today's episode. We'll start with a very interesting, funny bit, robotic pet, and then we'll slowly cover what are the different robotic manufacturers are out there, what kind of robots are being manufactured, when do we expect the new robots to come and fold our laundry, for example. So let's look at those in the next segment. So what is robotics? Robotics is the aim to have machines behave like humans and perform human-like tasks. This has been a science fiction lore for ages. We have seen many humanoid robots in science fiction films, and that has been the idea, to have those robots which can behave and walk and talk and perform tasks like human beings, have the dexterity of human beings, navigate a complex, varied environment, unknown environment like a human being without further training. But we only have robots which can only do very specific tasks in a very controlled environment. Like some robotic arms can only move one box from one conveyor belt to another, and that's it. So these are like pre-trained robots with very specific parameters and operate in very specific environments. Now, in order to have robots which can go explore environments like human beings and act in an autonomous fashion without any further training, required the discovery of a new field, which is the reinforcement learning. So a significant breakthrough in robotics occurred around 2016 with the advancements in reinforcement learning. So this technology enabled the robots to learn from the environments and their past experiences. And we talked about this. These are variation of this TD learning, Monte Carlo methods, early start Monte Carlo methods, Q learning, and there are many different other kinds of reinforcement learning methods that came into being. So this is not exactly how human beings learn, but these are very robust methods where an unknown environment can be learned very quickly, or a known environment, discrete or continuous environment, can be completely learned by an autonomous agent very quickly, an agent which is interacting with the environment. The reason it's so hard, because agent, even though it can model environment very well, if it's a simple environment like the game called Breakthrough, if you are playing a simple Atari game, then the environment is completely fixed and easy to model the environment, and the robot will learn it very quickly. But if it's an open environment, like if you have to navigate a field, if you have to navigate the streets of a bustling city, then it becomes very tricky, because the model of how human beings are interacting, how the cars are interacting in those cities, is constantly changing. So creating a predefined model in the AI agent's head is not going to help. It has to learn from feedback, and that is a variation learning method, reinforcement learning method called Q learning, where it learns from future episodes, or TD learning, where it can learn from future immediate feedback and then can quickly adapt to the environment and take further actions based on predefined rules that it has learned. Like human beings, for example, if we see someone is coming towards our car, we instinctively stop so that to avoid hitting them, right? So those are the things that it will learn quickly. Of course, I'm not suggesting the autonomous agents have to hit a few people quickly to learn that they shouldn't hit people. So those rules are automatically embedded, hard-coded into the system, but they learn other things. Like if they see a debris on the road, they will probably screech to a halt in order to avoid hitting that debris on the road. So those are the kind of things. So these breakthroughs, these things allowed the development of the self-driving cars and the robots capable of performing complex tasks without any kind of explicit programming. This is called, sometimes you'll hear people say dynamic programming. Well, dynamic programming needs a completely well-known environment. So when we say without explicit programming, we mean that we are not going to hard code any task. Hey, if you see a debris, you stop. We don't say it. We let it learn by running into the debris. Of course, we don't actually do it on road. We let the agent learn in a simulated environment which we create for it. With this, all the explicit programming goes away for any kind of scenario and learn on its own. It's akin to teaching a child to ride a bike. They learn balance and navigation through practice, not just by following step-by-step instruction. Okay, so these are all interesting reasons, and that's why we have progressed so far. So as always, I say that, okay, so what does the rubber meet the road? Robotic pets. Okay, so that would be the first thing that we will use, and we probably have seen those robotic dogs, and people have interacted with them in the early 2000s, and they were not that great. Yes, it can move and behaves like a dog, bark and maybe, but yeah, the interaction was quite limited. Have you heard of Luna? So this robotic pet is completely interactive. It displays emotions, it interacts, it gets angry, and it's amazing. Apparently people claim that it behaves almost like a robotic pet, almost like a pet, and people are saying that they prefer this over an actual pet, like a cat or a dog. So this is priced around $400 and has gained popularity for its emotional responsiveness and playfulness. Some users are finding it more endearing than real pets, as it doesn't require feeding or cleaning, I'm guessing. How this raises certain philosophical questions. I'm raising the philosophical question. Like, if the robotic pets become more preferable than the actual pets, what happens to the traditional pet ownership? Could species bred for companionship face decline? And in fact, that will happen. The ethical implications of replacing living animals with robots are complex. And there are papers which talk about this on the nature of companionship and human-animal bond. If we start replacing the animals with robots as our companions, as our pets, then those animals which are primarily bred for human companionship, those breeds will slowly fade away. Maybe not immediately, maybe not in a decade, but maybe in 100 years, most of the dog breeds would be replaced by robotic dogs. If that becomes a reality, of course, there will be some pushback. Most people will not accept that, but we have to accept that we have hundreds, thousands of dog breeds around the world. And some of these breeds will go extinct because they will not find any owners. The society has only a certain amount of holding capacity for any specific breed or species. If that species, and that also extends to any meme. For example, if you are a very specific, highly talented group of people who can create certain kind of fishing net which are in high demand now, but then it gets replaced by another kind of fishing net which is artificially manufactured. Guess what? You, like a fishing net building Maori, your scale will be lost in decades because people will not be using it. And the same thing with species. Any species which is not compatible, and since pets are mostly used for companionship, those breeds which don't have a large enough demand among pet owners who are actually holding out against owning robotic pets, those breeds will slowly fade away. And that's a reality that we have to face at some point. So these ethical implications are huge. Replacing living animals with robots these ethical implications are quite complex, and that has been explored in multiple papers. And this is not the forum to explore that, but that's something to keep in mind. Let's talk about something we all deal with: household chores, specifically folding laundry. In a recent video released by Tesla, we can see that the engineers are teaching the Optimus robot to fold laundry. And you might be wondering, why start with laundry? Now let's take a step back. Back in the days, washing clothes was a full body workout. And if you have not done it, I suggest you do it at least once. I have done it when I was young. It's not fun. People scrubbed and wrung clothes by hand, and I've done it. It's not fun. And you can spend hours every week just to keep up. Then washer and dryers were invented, and suddenly we had a bit of freedom. These machines save the average person about 6 hours per week. And if you have got kids, that number can easily jump to 10 hours. But here's the thing. These machines didn't just save time. They help change the society. In the mid-20th century, washing machines and dishwasher revolutionized daily life. They gave women, who were often the ones expected to handle these endless chores, the ability to focus on their own careers because they have too much free time on their hand. Like, they are not spending 4 or 5 hours every day washing clothes and washing dishes. So they can use those 4 or 5 hours of free time to forward their career, go to work, earn a living. So that's where women really got liberated after the advent of this. Of course, there's women's suffrage movement, and they did a lot of work. I'm not discounting the amount of work women themselves put them to have those rights. But these machines really helped gain their freedom back because their time is no longer eaten up by those mindless chores that the women were expected to. Remember, the women were still expected to perform these household duties till the late 80s during the revolutionary, those drug-fueled era. Before that, women were still expected to do those household chores. So, and during the 60s, these machines really helped women move forward because they freed up so much time. So it's not just about clean clothes, it's about clean slates for people for the personal growth and societal progress. So time is the currency, and we have to find every possible means to save time. And that's what I like, that this Tesla is teaching his robots to save time, to automate these mindless chores. So Tesla is taking this one step further. The teaching a robot to fold laundry might seem simple. Trust me, it's not. It's a very complex task. But think about what the time savings could mean. Imagine a future where you don't have to think about chores. Robots like Optimus now aren't just automating tasks, they're giving us the most valuable thing back, which is time. Just like those early machines redefined life in the past, these new ones could really unlock opportunities we haven't even dreamed of. There's so much time we can save from these machines. Now, this is crucial because one of the major issues with the Optimus robots were their hands were not really optimized for perform these human-like tasks. They have really worked on the hands and really optimized and upgraded the hands. They have sensor built into them, and now it can perform delicate tasks like catching objects mid-air. Let me repeat this: catching objects mid-air. Okay, that's not just cool, it's a big deal for robots working in a dynamic environment. And Elon Musk isn't just stopping there. Limited production starts next year, and he said by 2026, Optimus could be rolling off the production lines for just $20,000. Yes, for just $20,000, you can have a humanoid robot in your home by the end of 2026. It's insane. That is cheaper than most cars. So these bots aren't just factory workers, they're designed for elder care, hazardous jobs, and who knows what else. The sky's the limit at this point. Imagine having a robot that helps grandma with the daily tasks. Now, elder care has been one of the main use cases for these robots, and there are many personal robots that has been released for elder care, and elder care has been a significant issue in the healthcare community because there are not enough resources for elderly people, and many elderly people lack the resources or the retirement funds to hire someone full time. And even if they're on Medicare, that puts a considerable stress on the healthcare system, and not to say the taxpayer dollars. So if these robotic personnel can be deployed for elder care, they can be a huge help because they can give companionship. Even having a simple robot to talk to them can really help a lonely elderly individual. They can also call 911 if they recognize that the older individual has suffered some kind of a medical event, stroke, if they have fallen off the stairs, or they have just slept, or they are not responding. They have to have these kinds of mitigation methods which can only be provided by a constant surveillance system or an in-person, in-home caretaker or some family members who can provide this support. So this is great for people who don't have family, and this is really very beneficial for people who need these kind of support and don't have much resources at their disposal. There are many companies who are already creating these kind of personalized helper robots which are deployed for elder care. In fact, we're going to talk about a few of them. However, these are still in the nascent stage, and we have to be cautious about the efficacy of using these robots, and best to talk to a healthcare professional before making any decision. Without going into too much detail, there are four main players now in robotics. One is, of course, the Tesla's Optimus robots, and then the others that you might have already heard of is the Boston Dynamics, and they came out with the new version of the Atlas robot. And there are a few variations of their robot. They have like a dog-like robot, and then they have this humanoid robot, which is they're calling Atlas. So they are quite robust. And the other one, the Fourier GR1 set of robots, which are primarily targeted for industrial applications. And then there are a few others which are very niche, like the Astrobot S1, which is specifically designed for consumer level applications like vacuuming the floor, chopping vegetables, cooking dinner, and all those kinds of yes. But Astrobot has still a long way to go. However, the Boston Dynamics and Tesla's Optimus robots are already and kind of in like a pre-production. They are already released into in BMW's workforce, as the BMW has released that video where it showcases all those Optimus robots working in their assembly lines. And that's a fascinating video to watch. So the Optimus Generation 2 robots have the sensors on their fingers that we talked about before, which makes them very, very highly skilled at performing almost human-like tasks. And I'm going to post it again, where you can see those Optimus robots can interact with human beings, like with human tone, human style, human voice. And there were people asking the robot to sing their favorite song, and they thought about it for a while and then responded with a perfect response. And they are saying that in the back end, they are leveraging the OpenAI chat interface for those interactions, human-like interactions, which is interesting because of course, they need a high-speed internet to be able to perform that, and there is always some latency. Hopefully, the latency can be reduced in future. So I'm mostly intrigued by both the Optimus series of robots, because these are like multi-purpose robots which can act both as specialized assembly line robots and also for consumer grade robots which can be trained to perform human-like tasks. I'm also excited about the Astrobot S1, which is specifically designed for performing human-like tasks at home. So these are consumer grade ones. And then of course, if you want the industrial grade applications like robots moving heavy boxes, doing chores like that in an industrial setting, then Fourier GR1 would be the answer to all those problems. Other than this, then there is also another one I like to mention, although they are not the top of the line yet, Lynx of Deep Robotics, where Deep Robotics develop an all-terrain robot, which is like a dog, but it can navigate almost all terrains. And it's interesting, they actually revealed and they submitted their AI training, the environment they have created for the robot for which it can train. So these robots are not only just training on ground and all terrains, they're training in a simulated environment, and they have created a vast simulated environment on which the robot is literally learning to step on things, step on obstacles, blocks. So both Boston Dynamics and this company called Deep Robotics have developed a similar kind of robot, all-terrain robot, dog-like robot. The Boston Dynamics, it seems a little bit more advanced, and it has already been deployed in certain environments, especially factories, where it can go around and look at different machines and look at the parameters, if they're in toxic chemical spills and all those things. Of course, these are tasks usually assigned to human foremen, and their job is to go around and take notes, make sure that all equipments inside the factory are operating optimally and have optimal conditioning, because sensors don't always give the right readings, because although there is a reinforcement learning algorithm running in the back at the central computers, which is optimizing all those operating conditions, but unless we look at them physically, there are certain things that cannot be known. If there is a chemical leak, if there is a leak, if there's some kind of a spill, then the sensors might not detect that unless the factories have implemented visual AI vision, which can detect, but that's a costly option. So most factories usually employ a foreman who goes around and checks for leaks and any kind of damages to the equipments. Now those tasks can be hazardous at times because of chemical leaks and all the stuff. So deploying those Boston Dynamics robot to perform those checks will really help replace humans from a place of harm. So that's where we are slowly going towards. Now we can talk about the ethics of these things. Of course, the foreman lost their job and they are now replaced by this robot. Is that a good thing or a bad thing? So we can look at the trade-offs. Of course, it's a dangerous job. The foreman is making a living, but every day in exchange for the money, they are risking their lives. They are getting compensated because of the risks they are taking. Now we are saying that people are willing to take their risk for exchange for money, but we are saying that we're no longer willing to put human beings in harm's way, even if they're willing to take that compensation, take that money. In fact, this was already suggested by Adam Smith in the 1700s, the father of modern economics. It's like he noticed that some soldiers will literally almost put themselves to the brink of exhaustion. If they're compensated well, the people will just keep working if you pay them well. But we don't want that. That's why the overtime hours are regulated, because people, if they are allowed to keep working in order to earn more money, they'll just do that. People will harm themselves to earn more money. So we have a moral responsibility as a society to remove that incentive, to allow people to put themselves in harm's way as to get compensation if there is a means of doing that. Now, there are certain situations where we cannot mitigate that risk, because we need people to inspect those dangerous situations from happening and put themselves in harm's way. We need people to work in coal mines because the equipments were not good enough. But now we have better ways to mitigate those risks. So there is no reason to let human beings keep working in those dangerous situations and put themselves in harm's way. Now, this is not really a moral question. Some people will lose their job. Those jobs shouldn't have been done by a human being to start with, but they have to be done by human beings because there were no other alternatives. Now there is an alternative. So human beings should just gracefully remove themselves from those dangerous situations for which an alternative has arrived, and now reskill themselves to do some other things. Maybe learn how to program that robot that's doing that job on your behalf. Yes, maybe 24 man's job can be done by maybe one robot. Maybe those 24 men can learn how to program and learn how to control the robot part by part. Maybe they'll not earn as much, but at least they are not risking their lives. So there are different philosophical viewpoints. Some people will say, yes, no, we rather risk our lives. And some people like me says it's not worth it, and we shouldn't allow you to risk your lives because there is a better alternative. And this philosophical argument can rage on for hours, days, years. But the reality of the situation is the alternative has arrived. People will lose their jobs, but which is good, because these are the high risk jobs that are being replaced by robots. Robots are not taking human jobs that are productive for human beings. The robots are just replacing human from jobs that are already very high risk. So I see a vast opportunity growing, and this is a very exciting field, and we will keep talking about this. But for now, we'll just stop here. Thanks for listening. Talk to you next week. That's a wrap for today's episode of Machine Learning Made Simple. If you have questions or want to explore AI topics further, please don't hesitate to leave a comment. Until next time, keep exploring and enjoy your AI adventure.